Yeah. Okay. I realize I forgot to send out an agenda. Is Mike on? No, Mike Bartley.
Know that you'll have the results in a week. Yeah.
Hello.
Oh, hey, Mike.
Mm.
All right, hang on. In my geniosity, I forgot to send out an agenda for today. I'm going to send out a late notice to the group and give people a couple of minutes to join if anybody can make it.
Yeah, the link I had didn't work, and I only just got the email for this one.
All right.
I can share my screen anyway. For the
Yeah,
paper.
go ahead, please.
You want to review the paper? Yeah. Well, it's a skeleton. It's not a paper yet. It's a skeleton, but we're looking for contributions. So, can you see that?
Give me 1 second. Yep.
Okay, thank you.
All right. So we'll go over it in two pieces. We can cover it a bit today, and then do it again next week if anybody has any questions. I'm going to hop off at 8:30. So in case Cliff is nice enough to volunteer to wind up the meeting if I have to leave before we end.
Okay.
All right. So
Yeah, I mean, we can obviously do some work in between as well. So
say that again, please.
we can do some work in between as well. So
Yeah. Well, next
I
week
think-
it's about the OCP marketplace, so we should have it should be a 30 to 40-minute thing, and we should have some time after that to go over this again.
But I think we're trying to get this ready for February, beginning of February, aren't we, for the conference? So
That's the theory, yes, and hopefully do some work or make further progress after that as well on this issue.
Yeah.
Okay. Hey everyone, Happy New Year and everything. Today's speaker is Mike Bartley. He is going to talk about a test white paper, and that he is generated an outline for, and he's looking for fellow travelers. All yours, Mike.
Yeah, and also some people have said that they'd like to contribute. So I think people I guess there's two pieces of feedback here, and feedback on the paper itself and a desire to contribute as well. I've been speaking to a few people, but nothing definite yet. No one's 100% said they want to contribute. But the idea is a die-to-die test process. Okay. And so it's proposes a white paper, and we want to talk about this at the conference in Santa Clara, I think, isn't it? It's the Chiplet conference at the beginning of February. So, and anybody who wants to make a contribution will obviously be on the author list as well. So the objectives, so we've just broken it down into sections, who the owner is and what the basic content is. So the objectives for the white paper, an overview, it's probably best to start at the overview. And we're talking about, this is silicon test. So this is how we will make sure that a system and package coming out of manufacturing will be fit for purpose, basically. So bit like when you do a structural test or ATPG or for a normal die, that flow has to change when we do it for chiplets on a package on a substrate. So the question is here, how does that flow change? What do we need to do to make sure that we're getting good die and also good yield as well. We break it down into wafer test. So that's individual die. We can do probe testing on the wafer. Then we obviously cut the die from the wafer. And this may be, these are individual chiplets at this point. So it's not a system yet. These are individual chiplets that are coming out of that wafer. What's the test for the die? Then once they get packaged into the system, how do we test that system as well? We focus on die to die here as well. So this will be focused on die to die. It won't be general purpose, testing of other interfaces or testing of memories, etc., etc. This will be focused on the die to die interfaces. So that will either be a bunch of wires or UCIe, and the strategy should work for both. This is a level of strategy, and therefore it shouldn't really matter if it's a bunch of wires or UCIe. And I know this is for each of these steps. I know Bappy's keen to say, what's the objective of that step? What's the input to that step? What's the activity that goes on in that step, and what the output is? So, for example, what's the purpose of the wafer test? That's probe test is limited. Testing we can do, but you can eliminate. You can bin quite a lot of non-working die at that point. Once you then cut the die and test that, what's the objective? Well, we can actually start to do a lot more interface testing on that. And then package system input tests is how we test the final packaged product, if you like, ready for shipping to customers. There's a possibility as well that we can do some bench characterization of packaged die. You wouldn't do that per die, but you potentially do that on some of the die. So, for example, you can do sweeps of voltage, etc., and speed tests to just try and characterize the packaged die. You can also do that on individual die, or the final system in package as well. But potentially, we just normally do that on a packaged die, just to try and characterize that in a lot more detail. And how well does this actually give do we expect the system in package, the final SIP, to be well tested? What's the coverage of that final SIP? What confidence have we got that anything we ship will be properly working die? And again, that's from a manufacturing point of view. And if there's a design bug, then that goes into every single chip, and you can't really test that out. But this is for manufacturing, and what faults did we introduce in manufacturing, and did we sift all those faulty chips out, basically? So certainly we have to work very closely with the DFT architecture. I know Synopsys are potentially want to contribute to that. So that would be a useful contribution. We could potentially do that in TESOL if Synopsys don't want to, but hopefully we can include Synopsys on that. So that's the first key thing, is what's the DFT architecture needed to support that die-to-die test strategy. So for example, one of the key things we often do on high-speed interfaces, and we would consider this to be a high-speed interface, would be to enable loop-back testing. So what's the DFT architecture that you would need to do a loop-back test on a UCIe or a bunch of wires, for example? Or what? How would you shift in particular test data to enable that? How would you configure an interface to enable some sort of testing of that high-speed interface? Okay. So that's the overall DFT architecture, which feeds into all the testing that we do. And we've done quite a few chiplet strategies now and implemented the DFT architecture, and some of them are, some of these chiplet based packages can be, they could have 20-30 chiplets on there, and so each chiplet will need some sort of a DFT architecture to enable to be tested, but also tested once it's connected. So the first thing we would do is a die on wafer die-to-die test for some sort of wafer sort, which allows us to do probe testing and with a binning process. Hi, yeah, if there's any feedback yet. Was there a comment there? Okay, I'll keep going. That's done with probes because obviously they're still on the wafer. You're doing probe testing. And typical tests are near-end loopback testing. Okay, so that because you're not connected, you're doing a loopback within the chip itself. So you've got a transmit and receive ports, and you can loop it back on itself, but it has to be within the die itself because it's still on the wafer. Explain how the DFT architecture supports this potential issues. Then we can go to individual die. So once the good die have been cut out from the wafer, you can still do. That might supposed to say far end, I think. Sorry, I just realised there's an error there. Far end loopback and loopback testing, because now you can actually do a loopback on the test machine. So that's just you can now connect it up and do on the test board itself and loop back on the test board itself. So you can actually do what we would call far end loopback test. You would typically run a lot of structural manufacturing tests on that interface as well. And then once we've got the package die, we could do some bench characterization, as I mentioned before. Typically, they're looking at eye diagrams and jitter on that interface and those signals on that interface. Then we package it into the SIP, and then obviously during that packaging process, a lot can go wrong. So the individual die. Hello? Yeah, if there's any comments, feel free to interrupt me. So an individual die could be incorrectly assembled, so it could be broken when it got assembled, for example, onto the package. So you want to be able to rerun some individual die tests, but obviously now those die may not have any connection to the outside world, unless your DFT strategy enabled that onto that substrate. So you've got to have a strategy for and you don't really want to connect up all the die to the outside world either. So some of those interfaces which were external when it was an individual die are now internal to the package SIP. So how do we make sure those die-to-die interfaces are still working? And typically you want to put some boundary scan support into that so that we can shift in test vectors, but they might have to go via other chips. So one chip that is connected to the outside world, you might want to shift in data. So you've got die one connected to the outside world and die two that isn't, and you want to test die two, you may have to shift data via die one to get into die two to allow that interface to be tested. And obviously all that needs to be controlled as well. And how would you, what sort of test control do you need to enable that? And again, the DFT architecture plays a key part to enable that. Once you've tested the individual die, you obviously then want to make sure that the die, the individual chiplets, individual die, and for die here, you could just replace the word die with the word chiplet if you want. But now we can do die-to-die connect. Now we know each individual die is working. Its interface is working. Now we can start to test those die-to-die connections again. You probably want some far-end loopback testing to with some PRBS and lane connection tests. You could introduce some functional tests and do sweep the frequencies and the voltage on that. And then there's a lot of sort of CPU to configure all the lanes, use functional BIS to test. That's through silicon via physical lane testing as well. So if the die-to-die is going using silicon vias, then how would we test that? And again, DFT architecture, what are the potential issues? And then we've got some potential other topics which we could include, depending on how much time and how much space is in the paper that we've got. So there are ways to accelerate test. So SSN is a very popular method. So streaming, a way of streaming the data in, and shortening the, or more likely balancing the scan chains. We also use 1149.10. I should put .10 there as well. That allows us to use high-speed interfaces to push structural tests into the die and possibly also into the SIP. So you can actually stream the scan chains in. For example, the test data can be entered into the chip using a high-speed interface rather than the slower test interfaces, and you can get much accelerated test using that. Remember, it's important to try to run the manufacturing test as fast as you can because the test equipment is so expensive. That's why people are constantly trying to reduce their test time. To get more chips through, but also to reduce the test cost. And a lot of it's done in parallel as well. So you may be testing multiple chips or multiple SIPs in parallel on the same machine. Functional test, I know somebody was interested in functional test using AI test cases. So we do a lot of work called type of test called system level test, which allows us to effectively put the die, or put, in this case, the SIP, into a functional environment. So, for example, if it was let me just think of an AI, you might want to put that into an environment which would allow it to run AI tests. So, for example, you could download an image and get it to recognize that image, and then take the output from that. So the reason we run the functional tests like that is because as the chips become more complex, it's very, very difficult to get the test coverage that you want purely from structural tests. So if we regard BIST and scan as structural tests, they find it more and more difficult to get the coverage that you want to detect all the faults before it goes into the field. So quite often now you're supplementing structural tests with functional tests using something called system level tests, and a lot of companies are starting to do that now to get the coverage. So we could talk about that. Another important topic is redundancy. So, for example, you may have additional lanes on your die-to-die interface, so that if one lane is broken or has got a fault on one lane, you can use one of the spare lanes, and you don't lose that whole SIP. So, for example, if it was a 32-bit signal interface, you could have two spare signals, so that two spare lanes, so that if one lane was faulty, you could use that spare lane, and you've still got working die. So the cost there is those two spare lanes, but the return on investment is less faulty chips. So there's obviously some maths to do on that. Okay. And then try to put in some results and then some conclusions. That's the paper, Bappy. So we're obviously looking for feedback now or just via email, and whether people want to contribute on it. I think we've spoken to about 3 people who potentially want to contribute, haven't we, Bappy?
And what do you see as the before and after of the white paper in your mind?
In terms of
Like what's the value? I guess in terms of like what is it that we have before the white paper exists that we don't have before the white paper exists that we will after it exists? Is it a compendium of these are the things you should take care of, or is it you think it's a recommendation of all?
it's just I guess it's just some thought leadership from our group as to say, when you go into this, if you're thinking about doing package-based systems, then these are the things you need to think about from a manufacturing test point of view. And so it's just as I guess as a group that's working on die-to-die the bunch of wires, and we're recommending people to use bunch of wires, then we should be also giving them a test strategy to make sure that if they're going to make chiplet-based packages, then this is something they have to do. If you don't do this, then your yield's going to be, or you, worst case, you're going to ship broken die, and you're going to get a lot of returns from the field. So this is effectively something people have to do, and people understand how to do it for die. This is nothing novel for doing chip manufacturing tests for chips. What the novel thing is now is that you're starting to try to put those into a system and package on a single substrate, and you've got less access to that than you would maybe if you were putting these things just onto a normal board.
Got it. Okay. And the only sort of delta that jumps out for me, and it's is a pointer to where standards exist and where we need them in each of these things, where they'd help, or standards aren't actually. Are standards needed? Do they exist? Or this is where maybe either our group or somebody else should do something.
Okay, yeah, that's a good point. I'll just add that in now. Let's just add that in rather than take a note and add it in later. Standards.
He just was here a couple of weeks ago. Oh no, it was a bow meeting. Talking about his P3405.
P3405. Yeah, I think we had there. Okay. Okay.
Okay, I'm going to hop off in about. I'm going to make Cliff the host so that I can hop off in about 3 minutes.
Okay. Well, it's sort of thrown open to the floor now to see if there's any feedback, whether anyone thinks this is a good idea, bad idea, whether they want to contribute, whether they want to give some feedback on the content.
So this is Anshu Bahadur. I joined a little bit late, but one question, maybe naive, is there like a cost component of it? Cost savings or from the standard, not just from the standardization, but from this whole process?
You could put that in, certainly. I can add something in on that. Cost implications.
Actually, that's a great point. And the other one related to Anshu's question is die size.
Yeah.
Die size versus, how does chiplet size, if you set line size, and the impact testing costs?
Okay.
So if you make a 20 by 20 die out of 4, it's going to be 8, right? 16 5x5s, or if you make it out of 4 10 by 10s, what are the cost implications?
Is that what you mean there? Compare with cost of monolithic die. Yeah.
Across the board, right? Also, just the chiplet sizes. Do smaller chiplet sizes lead to higher test costs, lower test costs? And whether there's going to be a process node impact.
Yeah. Okay.
Oh yeah, and hey, I'm going to hop off. But for any participants who joined late, if you would please go over the schedule and what you expect, etc. One more, and Cliff can help you out, and then on that I'm assuming so.
Okay. So yeah, thanks, Beppy. Yeah. So if there's any more feedback, just let me know now. I'll send this out. But I guess one of the things we're asking, I mean, we can change these. Testhold doesn't have to do all of this. We can change that to whoever wants to make that contribution, or we could do it jointly.
Mike, I need to also hop off, but I'll be interested from the cost implications perspective.
Okay, you want to contribute to that part?
Yeah.
So I can't see who's speaking.
Yeah, I'll text you my name and affiliation.
Anshu Bahadur.
Yeah.
Yeah, but I'll put you down there. Thanks, Anshu. That's very helpful. And I'll put you in there. I know you got to jump off, but yeah. Okay.
Thank you.
Thank you. Thanks, Anshu. Anybody else? I can see people.
Yeah, Mike, this James here, James one we spoke earlier before. So yeah, probably just we'll follow up with you then. I think like either on the email or text and see would like to have further conversation on this.
Okay. It's Jin Yang, is it? Did you say?
James Wong.
Oh, James Wong. Yeah. Okay, James. Yeah, yeah. We did good talk. Okay.
Yeah.
Okay. That would be useful as well. Thank you. So I'll add you into. Well, which part would you best work on? Do you think, James?
Not decided. That's why I want to see and talk and see where things are. I think a potential area could be the DFT architecture potential. Yeah, other a few system level testing, many a few different areas. But right, I think when in the meeting I can talk more about and see where things are, and then I can see like what you already have, and then what things I can help to contribute.
Okay. Yeah.
Those are the
Okay.
yeah, what's that?
Thanks, James. Thanks, James. Anybody else?
This is Quinn
Nice.
Jacobson. Go ahead.
Okay.
I said, this is Quinn, and I'd be interested to help with the DFT architecture.
Okay. Perfect. Quinn Jacobson. Yeah. Thank you, Quinn. Oh, sorry if I spelled your name correctly. By the way, I'm going to put this online, so we'll probably use Google Docs for this. So make it
Yeah,
easy.
you can share this one. That would be great. Yeah.
Okay, Quinn, and I think somebody else was speaking at the same time as Quinn. Right? Was there somebody else?
No, I think that
Boon Chong, ABC. I think we spoke before.
So who else?
Boon Chong, ABC.
Ah,
We
Boon
spoke
Chong.
before, so my
Yeah, Boon Chong. I think we spoke before as well, didn't we? Boon Chong, yeah.
yeah.
And you can make a contribution, Boon?
I think maybe also help out on the DFT or the standards part.
Okay. Thank you. And I'll put you into the standards as well. That'd be useful. Yeah, I think the more we can make this cross company, the higher the quality of the paper as well, because obviously more cooperation, more people leading on this gives us a better profile for when we present the paper. Thank you, Boo. And is there anybody else? Again, I think. Did I miss anybody? And we have a good cross section now. Okay, Cliff, then I'll leave it there, Cliff. I think we've got some good contributors now. And I think we've got some good feedback on the paper, especially in terms of the cost and the standard. I think that's very useful feedback. And I'll connect with those people separately. Okay. Okay, Cliff. So I'll go back on mute. And I'll hand over back to you, Cliff. Okay, thank you.
Okay. Thank you, Mike. And before I have a few announcements to share with everyone before we close the call, I wanted to check to see if anyone else wanted to add anything to the call today. I'll give it a few seconds. Does anyone else have anything they would like to share with the group today? Okay, well, if you have a chance to think about it while I make the last couple of announcements, I wanted to remind everyone that we have two important events that we're currently running up to for the first part of the year. There may be others, but the first two that I'd like to remind people about today is one, we have the Chiplet Summit that I think someone already mentioned that's happening February 6th, 7th, and 8th in Santa Clara. And on February 6th in the afternoon, the OCP will be holding a tutorial that will span the afternoon from 1 to 5. And we will be sending out invitations to all the people on the mailing list for ODSA. So look for something from us next week, and hopefully you'll be able to attend. For people that sign up through the OCP and our invitation, attendance on day 0 for the tutorials will be complimentary. If you go to the website of the Chiplet Summit, you will end up paying for day 1. So keep that in mind. Not all links are going to be equal. So please, since you're part of our community, sign up through the link that you'll get in our communication to get a complimentary pass for day 0. We'll also be publishing a set of speakers that we're working on for the tutorial. The other element of presence is the OCP will have a booth on the exhibit floor. And we've also invited some non-commercial demos to be present in our booth around the open chiplet economy. So please come visit us on the exhibit floor. And the other thing is we do have a keynote, which I believe is going to be on the 8th morning. So please look out for that as well. And please come out and show your support. The other thing that's really important is we have the OCP Regional Summit in Lisbon. And the call for papers is now open. So please think about submitting a proposal. We would love to have enough content that we could justify an afternoon or morning full session on the open chiplet economy. And we can only do that with the support of the community and you putting in your proposals. So, and I believe the call for papers for the regional summit in Lisbon, that's April 25 and 26, I believe, is going to close very early in February. So you have a couple of weeks to get your proposals in. And perhaps if you can't travel, if someone in your company is in Europe and they can attend, that'd be awesome. So that's it for me. I don't know if anyone else has any other things they would like to mention to the group before we close the call. Okay, going once, going twice. Thank you everybody for attending today's call. And I look forward to seeing you on subsequent calls and also at the Chiplet Summit on the 5th or the 6th, actually. Take care.
All right. Thank you. Bye.
Bye-bye.
Bye-bye.
Hey, Cliff, I think I missed it, but is there like some kind of a promotional or any discounted entry for the summit?
For regional?
No, for the February 6th or whatever.
Yes, so for February 6th, the tutorial, if you sign up using the invitation that we are going to send out, using the link that we put in our invitation, the day 0, the tutorial day will be complimentary for you.
And so, but you got to pay for the subsequent days, I guess, right?
The subsequent days you need to pay for at the rate of the 2 days for the conference, yes.
Okay, got it. Thank you.
We weren't able to get a complimentary pass for all 3 days, and I think the way they work the discount is that they're giving the day zero complimentary for ODSA people.
No, so day 0 is complimentary only if you sign up for the next 2 days, I guess, right?
No, you don't have to. It's day 0 is complimentary, and if you only want to come for day 0, that's fine.
Okay. Sounds good.
Okay, well, hope we'll see you there. Take care.
Yeah, thank you.